Hello, hello. Hey, Diggs. How's it going? Just going to do a quick audio levels test. Make sure mic. Whoa, sounds quite loud. Might. No, I think that's all right. Yeah, okay with that for the moment. Right. I might look for some different music to have on in the background. As normal, we've got some white bat audio music going on. But I might swap over to something different soon. Right, so where we got up to yesterday, we started looking into sprite swapping for our little game here because we want to start bringing in different characters. We've got the king of each suit in the game so far. Just load it up so you can have a little look where we got to. But we're going to start on animations for the Queen, the Jack, the 10, and the Ace. And the idea is to be able to make certain poker hands by like choosing who you knock out of the ring. It's still a fairly basic little like pixel art game that we started making for Ludum Dare a couple of weeks ago. But we were starting to look into swapping out these sprite sheets. So rather than having individual sprite sheets and animations and all the like character controllers and all that kind of stuff, I think in Unity there's this thing called Sprite Swap or something like sprite libraries and that kind of thing that we're going to look into, so that we don't have to have loads of different animations is the idea. Because all of these are basically exactly the same animations. If we look at the animations here, we go through each of the character sprite sheets and we select the same sprite off of each. But we need a separate one because it's different sprite sheets. So that's what we're going to be looking into today, is this sprite swap option with the flipbook animation swap setup. So we'll create different sprite libraries for each character, and then use a default animation like the scavenger's animation, and use the sprite renderer component to set the sprite property from the sprite library. Now, I'm not sure if that actually makes sense, but that's kind of the understanding of where I've got to so far. But before we start all of that, I'm just gonna have a little look through Whitebat Audio to see if we can get some other audio in the background that might be a bit more suitable. So we want something that's long form. Nostalgic synthwave, that could be alright. Let's see what this is like. This could be alright. I'm gonna leave that on for the moment. No need for more horror. Right, okay, so I think what we want to do to start with is make a new prefab. So we started with this character prefab. I think we want to re-establish how everything all works together. So I think really what we want to do, what do we use? Do we use Figma for this? Or Leonardo? Let's go with Figma. Just pop that over here for a second. We're going to set up with a new file just briefly. Okay, so what we want is maybe not Figma. Let's just see here. So we want a generic character game object. Maybe the problem with Leonardo is that mouse and keyboard is going to be really iffy. Maybe OneNote might be better. And we go to games. In the ring. Right, so we want a generic character that on top of it, on the game object, we either attach the player controls, player input controls, or the enemy AI controller. It's not really an AI. Let's just call it controller. That's what I can type today. So that will be insert. And then on the character, we want something that deals with the movement. So that's the movement script and the enemy and grab scripts. And then we want something that controls the animations. And on the animations, we want sprite libraries. Or maybe the sprite renderer. So maybe that's the setup we want to look at. And then on the movement script is where this is only where we really care about these grab position, etc. grab, drop, and ray. So I think that's what we're going to go for. Gonna have to have a little look around. Get rid of that. Cool. Sorry, just dealing with bots in the channel. Okay, right. So, I think that's the kind of setup. So we want a prefab here character that controls the movement and also has animations on it, but the animation selects based on a sprite library. Or do we want... Actually, I think what we want is suit on top of this. So this is just a generic character. Yeah, I think that's what we want. I think we want a generic character, and this is the selected character. So this is the value and suit of the card. And then on top of that, you can either have the player input controls or the enemy controller. Let's work with that for the moment and see if that works. And this really is where we want our character stats slash attributes. And then this is the character prefab underneath. Yeah, I think that's what we want to go for. Which might mean a bit of a redesign on all this kind of stuff, but it shouldn't be too bad. So I think actually, do we even want this base character? Do we want to just start from scratch? Right, okay. We're gonna say that we want an empty game object here, which is the animator. Because the animator is kind of agnostic to which sprite it's using. Yeah, let's do animator. And on here is where we want the character animator. I mean, honestly, it could just be on the character rather than down here. Can't move this one. Why can't I move this one? Right, I'm going to remove that. And these three are just locations on the model. Do these need to be game objects? Probably not. So I think I also want to just make a new folder with an idea of making some new movement scripts. So let's do that. Let's do create folder, character. Let's just call these character scripts. And in here, we want to make a new script, which is going to be our... Can I just call it movement again? Is it going to not like that? Seem to be okay with that. Yeah, it doesn't like it. Okay, let's go back into here and rename this as maybe let's call this rigid body movement. Rigid body movement. And we're just going to copy that as well so we can paste it across. Right, so this is going to need our rigid body of the character. And I tend to prefer to write out in full everything. And really what I want to do is just have like public methods. Or maybe protected methods. I can't remember what protected versus public versus private, and C# Unity. Right, so class A. Can't access text 1 because it's on the private string of class A. But because class B builds on class A, text 2 is declared as protected in class A, so it's accessible. Yeah, so this is what I want to do. I want to have protected methods here. Right, so we don't care about this. We don't really care about these. So we want protected void apply force, something like this. And from this we want a vector 2 direction and a float power. And this is just going to be rigid body dot add force direction power, right? Ah, no. Okay. Direction. Can I do directions times power? And impulse. I'm not sure if I have to make a new vector 2 first. Let's log the direction times power. Force vector. Okay, so how do we want to call this method? To make it obvious. I think what we want to do, I think we want to set up a separate test scene now. Which can be almost a copy of the standard game scene. Let's go back to that. We'll take a copy of this. Maybe. We should be able to just copy it, right? Let's duplicate it. There we go. Right, so test scene. This is what we're going to look at. Don't care about the level loader. Don't really care about the menus. The rest of that stuff can stay in. Right, I want to disable our enemies here. Save that for the moment. And then so if we build this off of the rigid body movement instead, then we should be able to do apply force. So instead of this, we say apply force vector 2 dot up jump power. So that should be identical with our jump. We shouldn't have to change anything. That should already be applied to the character. It's just a case of separating out the different parts of the code, so it'll be easier to maintain. I understand at the moment it doesn't really do anything unique, because this is just doing a standard function here. No. Oh wait, we've got our enemy spawner on. Let's turn that off. Right, so why did that not work? Console. Object reference not set to an instance of an object. Rigid body. It doesn't know what the rigid body is. Is that true? Yeah, because we need an awake. So we do an awake. We do that. We do that. And then that should look onto the movement script and find the component, I hope. Nope. Now, do we want to apply... Do we want to pass the rigid body down? I mean, also, we're going about this the wrong way. We don't really care about this at the moment. So let's go back to what we were doing. This can all wait. And here, we just cut this back. I always do this. I get distracted by something else that I think I should be doing. So really, in this situation, I want to get rid of all of these in here. And we're going to add our character. No, prefab. Let's put you more towards the middle. Right, so this character we don't want to give you a sprite here. Let's do a new script here. That is our character movement. Character movement. And this is just going to be a copy of the other movement script rather than this one here. Oh, actually, while I'm waiting for stuff to build, I did want to test out the new Twitch shout out command. So let me just have a quick look at this. Now, is this going to be how this works? So, sorry, I'm going to use my mate's Twitch for this. Does that work? Can I even, does that even work? What if I just do, yes, if I do that, Maybe if it's the first line of the shout out. Sorry, bud. So stream elements, line break in command. This is 2 years ago. Maybe someone's found a way to do this. And commands. So you can do lots of dashes. No comments, great. Right, let's see if this order works though. Let's try this. Did that do anything? No. What if it's just the command? Does that work? Do I have to change settings in my chat? Settings. Manage mod settings, maybe. Appearance messages caught by automate mod. Let's manage moderation settings. Let's see if that's in the settings there. Okay, Twitch allow mods to use shout out. Broadcasters and the mods can enjoy using the features. Okay, so mods should be able to do it. Okay, looks like we're just going to have to go back to the old one, and then we're just going to manually include the shout out. Let's just see, does this only send to Twitch? Yeah, okay. That's quite cool. Restream is so useful. Right, get rid of you, get rid of you. Don't care about those. Right, let's get back to this then. Okay, so we've got our character here that's going to use character movement, and character movement is just going to be a copy of our movement script. So we can start hacking up. This will all resolve as soon as I call this character movement. Oh, that's global namespace. Ooh, probably don't want it there. And then we can do this. Oh, that's quite useful though. I should just have the public enums in one place, I think. Right, so on this character, I want to get rid of movement. And we're going to put character movement on. How do we set this up? Selected character. So I think all we want to do is go back here and do an empty, which is our selected character. And we want this to be part of this. And this is also going to be a prefab. And this is where we want our parameters. Which we want to just use our some variables. I can't remember which way around these work. Yeah, this way around, right? So how do I... I want a generic block here that allows me to pick suit and value, and from that determines the rest of the characteristics. So can I make like a drop down option? Unity, what's this thing called? Called Inspector. Inspector drop down? So have a quick watch of this.
Hello friends, today we are going to check out how we can create a drop-down list like this in the Unity Inspector window. So first of all, we have to open up the script, type in enum and give some name that is not used by the Unity already, and give inside in the inspector to use.
Was that? Serialized field that uses the enum type. That's nice and simple. Okay, so we want here in our character script, we want here a new script which we're going to call character selector. Character, yeah, selector is fine. I'm going to open this up, and all we're going to do here, now inside or outside? Outside of start, but inside of the class, okay? So enum suit, that's going to be diamonds, no clubs, alphabetically, clubs, diamonds, hearts, spades, and then serialized field, suit, See? I don't think I've got to do them in... No, it doesn't look like I have to do enum with strings, do I? No, left, right, okay. So if we go back to here and apply the character selector to the selected character, we should have a drop down for nice. That's what we want. And we also need another enum. So I guess these can't be private enums, right? How did we do it before? So this is a public enum here. And we're going to call this value. And this is going to be ace, king, let's get rid of these, queen, jack, 10. And do that. Right, does it matter if it's private? I'm not sure that's the right place for that, because that's in global. Right, so this is selected here. Then in here, I think these kind of things, I want to be able to look up the chain. But on awake, right, Unity get value from parent. Transform.parent.gameObject. Parent of the transform. from parent game object. I've got a feeling there was a video by BMO that kind of does this. Do BMO Unity then. I think it was something about power-ups somewhere here. Yes. Kind of, I think. Might be this. Pause that a second, let's see.
In 2016, 2017, it was pretty common to see your average Unity project dig themselves into a hole with highly coupled, tightly dependent code bases. In fact, I'd say it was the standard. And part of that reason is because using mono behaviors as your primary driver really makes it easy to fall into that trap. After all, you attach mono behaviors on your game objects, and now in order to test certain functionality, you need several game objects in your scene at all times, just for your systems to actually function. Then, out of the dusk, Richard Fine and Ryan Hipple both gave talks at Unite, the Unity convention, where they talk about using scriptable objects in interesting ways to break these patterns. People were going nuts after Ryan Hipple's talk. I remember feeling like I couldn't escape hearing or reading about it on YouTube or on Reddit or some forum, and the reason I think it profoundly impacted people was that it changed their perspective on how a Unity project could be set up in a clean and testable way. And this was kind of new at the time. People were still kind of feeling out Unity as it grew in popularity. And then it kind of fizzled too. I think as people tested these things out, they realized it wasn't for every project. And so I do want to say that up front. Everything I'm going to talk about here in this video is not going to be, the one-size-fits-all solution for every game you're making, especially if you're on a small team or a solo developer. But it still is important to learn because it's a valuable tool, and it also will shift your thinking on how to structure your code so that you can maintain it in the future. So with all of that said, I want to show you how to make variables using scriptable objects, because I think when Ryan Hipple showed that in his talk, it really blew people's mind. They never really thought you could do something like that. But before I just dive into it, I want to show you quickly my problem statement here in the scene I have set up. Okay, so in my example scene here, I have my player, I can move around, I have a scarecrow enemy, and I have this health bar at the top. And right now I have full health, but if I walk into this scarecrow, you'll see I take damage, and it reduces, and if I do this to the point where I'm pretty weak, it'll actually start playing an audio sound, which is this heartbeat. Pretty simple stuff. Now let's quickly take a look at how I have this set up. So looking first at our player object here, we have this player health script. And if I open it up, it's really simple. It's literally just two floats, a health and a max health. And we have this function where we can take damage, where we pass in an amount, and we reduce our health. On our health bar object, we have this health bar script. And you'll notice we actually have a reference here to our player health script. And this is so we can have our player health and our player max health, and we can decide, what percentage of the health bar should be filled up based on these two values. But right here is an issue. We have a hard reference to our player health script. So these things are now tied together. In order for us to ever test this health bar, we now need to make a player or some object that has a player health script on it and populate the values. Moving on, we also have this audio manager class with a similarly named script. And if we open this up, we'll see we have a reference to player health here as well. And all we're basically doing is checking if the player health is, like underneath a third, and then we'll play this heartbeat sound, otherwise we stop from playing if, they have higher health. But here we have another hard reference to this player health script, just so we can get these float values out of it, which isn't the biggest deal, but it kind of is a pain. Because if we ever wanted to test this in isolation, right, we want to say, hey, is my audio manager working? We now have to make an audio manager, and again, like the health bar, we have to make a game object, attach the player health script, and populate the values, just to test this one component. And this is a pretty simple example, like, that's only gonna take a little bit of time, but you understand, we're making hard dependencies here, when there really doesn't need to be. And it's actually just gonna make testing your project much more difficult. It also makes this component so rigid and narrow because we have to use this player health script, when really what it should be doing is just looking at a float value for health and max health. And so this is the problem, and this is what we're going to be fixing by making variables with scriptable objects. And so if you don't know what scriptable objects are, I just put out a video that kind of introduces what they are and how to make them, but I still think you can follow along here. Let's go ahead and make a float variable scriptable object, and this is the example Ryan Hipple uses in his project. So in our assets folder, we'll right-click and create a C# script, and I'll just call this float variable. And let's open it up. Okay, so in our script, let's get rid of all the start and update methods. And to make this a scriptable object, we don't want to be inheriting from mono behavior. We want to inherit from scriptable object. And then to be able to create this in the menu, we can aptly add a tag in square brackets and say create asset menu. And then for the actual scriptable object, you know what we want to store in here? A public float value. And that's it. And I think he makes a joke about this in his talk. We literally are just storing a float value in the scriptable object. So now we can go back to the Unity editor, and I can right-click.
I think this is what we've got set up.
And right at the top, we'll see we have a float variable. So if I click this, I can call this something relevant like player health, and with this new scriptable object selected, we see in our top right we have value, and so we can set this to whatever we want. So let's set it to like 800, and here's something I want to show off really quickly. We can play the game, and so it might be hard to see because my screen's blue, but even while the game is running, I could change the scriptable object value to something like 50, and normally when you stop running the game in Unity, it resets all your values to what they were when you first started. But in the case of a scriptable object, because this is actually being saved in the project and not during runtime, when we stop running, the value persists. And this is true for when you change levels.
That's so useful.
So that is something you need to take into account. If you want this to reset every time you start the game, then you'll need to incorporate some sort of value for doing that. And at the end of the video, I'll give you a reference for how you can set things up like that. But this also saves you the effort of having to have all these different dependent game objects travel with your player into new scenes. If you have some singletons like this audio manager or a game manager, you don't need to bring them in every single one of your scenes in order for some functionality to happen. You now have this single variable that you can reference. So now I'm going to quickly go through how to modify this existing project to use these float variables. And I'm actually going to make another one here. So I'm going to create float variable, and I'll call this player max health. And so we'll set this to 100. And so now that we have these two float variables created in our project, player health, player max health, we want to create a class that actually consumes the float variable type. And this will make more sense right now. Let's do it. Let's create a new script, and we'll call this float reference. So this float reference object is what we're actually going to be using in our other scripts like our health bar and our audio manager, and it will make sense by the end of this. So stick with me here. I'm going to use the example Ryan uses in his talk. We can clear out our script, and we don't want to inherit from mono behavior or anything at all. We just want this to be a public class. At the top, we can put in...
Right, we did set this up, I think, in our helpers. Yeah. So we've got those enabled. I think really we want to have a look at this stuff.
So that's what we actually configured in that string quotation from the menu name. It does some effect to your character that powers you up or restores health or something like that. And we're going to be doing this all with scriptable objects, so the code's going to be nice and clean and decoupled. So let's just jump into it. I have a 2D Unity project here, and I have been making a couple videos on how to use scriptable objects in interesting ways, so check those out. But you don't really need to. You can definitely follow along without knowing anything about it. Anyway, so here we are. In my game, I have this player that can walk around. I have a health bar that shows I'm currently damaged, and now we want to add some power-ups that we can walk into and pick up. And again, we're going to be doing this with scriptable objects, and that means down in our assets folder, I'm going to be able to right-click and go to create and make a bunch of power-ups, whatever we want.
Right, I think what we're going to do is switch this over to put it in our research window here. So this should now show it in the corner of the screen. Even if I put it on this other screen. Yeah, good. Let's make sure we get that it's from demo. Just about.
Down here. And I'm going to talk more about it as we go along, but this is what's going to be called the delegate object, because our scriptable object is going to be responsible for actually applying, the individual power-ups to our players. And that's going to be really cool. So let's go ahead and create our power-up scriptable object. And so I'm going to create a new C# script, and I'm going to call this power-up effect. And we'll open this up. Okay, so we have our power-up effect script here, and just like all Unity scripts, we are defaulted to inheriting from this mono behavior, and we don't want to be doing that. We actually want to inherit from scriptable object, but we can actually get rid of update and start, because this is not going to be a fleshed out script. This is going to be our abstract script that we build power-ups out of. So the first thing we want to do is in between public and class here, we want to make this abstract. And this abstract keyword means that we can never actually initialize this power-up effect class. Like, you can't make an instance of power-up effect. But what we can do is inherit from this power-up effect. So you can make something like a health buff effect or something like that that inherits from this, and then that health buff can be instantiated. So I'll show you how that works in a second. But the only thing we want to have in this abstract class is a single method. So we can say public abstract void apply. And we'll pass in a game object, and we can call this something like target, right? Because this is going to be the target of the power-up. It's probably going to be the player. In our example, it definitely will be, but maybe you're also powering up enemies or some other game object in your scene. Who knows? Cool. So we have an abstract class with an abstract method, and this is basically just going to be a template of what we want our scriptable objects to be. So let's go ahead and implement our first one. So we'll go back to the editor, and I'm going to make another quick C# script, and I'm going to call this health buff. And we'll open this up. So we have this health buff script here, and now we actually want to inherit not from mono behavior, but from our power-up effect. We can get rid of start and update, and you'll see it's complaining. It says we're not implementing our abstract member apply, so we actually have to make that apply method. So if you wanted to implement this, what we need is to make an apply method that takes a game object argument. So we can say public override, because we want to override this method from our parent class here of power-up effect. We have no return type, so it's void, and it's called apply. It takes a game object target, and we can get rid of this exception that gets defaulted. So what do we actually want to store on our health buff? Well, we probably want to configure how much health we want to restore, right? Or maybe even how much health we want to lose if we pass in a negative value. So what we can do is say public float amount, and then we have this game object target, right? And the target is whoever the buff is being applied to. So in this case, it's going to be my player, and my player has a health script on it with a health and max health value. So what we want to do is access this health script and change the health value. So what we can say is target.getComponent. The component we're looking for is health, and then we just want to access the health variable. In my case, I'm using float variables, which I just talked about in my last video. So we want to get the value of that float variable, and then we want to plus equals the amount that's being stored on this health buff. And that's it. That's all the code we're going to write. And just like that, we have our first buff created in our game in just like 5 lines of code. Really, really easy stuff. The last thing we want to do is, because this is going to be a scriptable object, we want to be able to make this in our asset menu. So above our health buff class here, what we want to say is in square brackets, create asset menu. And then this is optional, but if you want to have it kind of configured nicely, what you can do is open parentheses and say menu name, which is just a parameter for this create asset menu. And in here, what we can do in string quotations, we can say powerups/health buff. Just like that. Because we're going to be making a couple types of power-ups, right? So this is just going to organize them nicely. And so with that done, we can actually now go back to our Unity editor, right-click on our assets folder, go up to create, and you'll notice at the top here it says power-ups, and we can actually expand this and you'll see health buff. And so that's what we actually configured in that string quotation for the menu name. We have now a little folder here and we can put all of our different power-ups, and everything's just kind of organized nicely. But let's actually select this health buff, and I'm going to call this minor health buff. And I'm going to right-click on assets and make another one of these. I'm going to call this major health buff. So clicking on our minor health buff, or it doesn't really matter which one, you'll see the only thing we can configure in the inspector is the amount. So let's go ahead and do a quick example. For the minor health buff, I'll set the value to 25, and for the major health buff, I'll set the value to 50. So we now have this scriptable object power-up that we can make in our asset menu and configure in our inspector, which is great. And the scriptable object contains all the logic for applying the power-up, right? And this is really important. What we're missing now is an actual game object in our scene somewhere for our player to collide with, and then apply that power-up. But now we have separation of concerns. We can now make a game object that has a collider on it, and this game object can just worry about colliding with a player or, whatever game objects you want to apply power-ups to. And then the scriptable object is entirely responsible for applying these buffs and debuffs to things. Right, you don't have to really mix your systems up too much here. Everything's pretty separated nicely. And so this is a really good way of going about it. But let's go ahead and actually make that game object that collides with our player and get this thing working. So let's go and use a square. I'm going to right-click on our hierarchy and go to 2D object, sprites, and I'm just going to click square.
Right.
Maybe I'll make it red or something. And we'll call this health power up. I'm going to add a box collider 2D. And I'm just going to set isTrigger set to true. And then I'm going to make one quick script and call this power up. And we'll make sure we attach this power up script onto it. And let's open that up. So we can get rid of start and update again in this power up script. We don't need it. And this time we actually do want to inherit from mono behavior because we need this to actually be a script we attach to our game object. Now, we don't know what kind of power-up we're putting into this, right? We just know that we want to collide with the player. So what we can say in here is we can say public power-up effect, and we'll call the variable power-up effect. So we're going to be passing in a power-up effect, we know that. And then we just want to apply it to whatever we're colliding with. So we need to check for collision. And so we'll do that like we always do. We say void on trigger enter 2D. We can destroy our power-up as soon as we collide with it, so it goes away. So we can say destroy game object. And then right after we destroy our power-up, what we want to do is apply our power-up effect. So we can say power-up effect dot apply, and we want to apply it to the collision dot game object. Because this is a collider 2D, this collision object, but our apply function actually takes in a game object. So we actually want to reference the game object here. And that's it. This is all you need to do, right? All the script's doing is saying, hey, did we collide with something? Oh, we did? Well, let's destroy the game object and apply the power-up effect. And maybe you only want this to apply to player objects. So you could do a check here for if it's a player or an enemy type. You know what I mean? Like you could put this check here in an if block and then apply the power-up. Because maybe you don't want anything colliding with it, but in our case, I don't really care. This is where the check would go, though. So going back to the editor, we now have our health power-up game object with a power-up script, and in that script, we have a power-up effect variable we can pass a scriptable object into. So let's go ahead and put in our minor health buff. We expect this to restore 25 health. If I play the game, you'll see if I walk into this thing, we expect it to destroy, and my health should go up, and that's exactly what happens. I could duplicate this health power-up object and move it over, and for this duplicated value over here, let's pass in our major health debuff. And I'll make this one like yellow or something so you know they're different. And so now I have pretty low health. This red one should only restore a little bit of health, so it barely got me halfway. And then we expect this yellow one to heal much more health. And it does, it almost fills my health bar up. So just like that, we have two different power-ups we were able to make in the inspector in a flash, right? And so now, let's just say we want to add one more type of health buff into the game, or in this case, a debuff. So we could say minor health debuff. And let's actually pass in a value of like -25. On this red one, without changing anything, I could just click and drag our minor health debuff into the slot instead. And now when we play the game, we now expect my player to lose health, and we do. Do you see how fast that was to build things out? And we built the system out in a way that we don't really have to worry about things breaking or being too dependent on each other, which is really, really great. Okay, so I think I illustrated the point with these health buffs, but let's actually make another type of power-up. How would we do that? So we can actually make a
Interesting, but I'm not entirely sure this is what we want to use.
And just like before, we can remove the guts of the default script. Instead of mono behavior, we want to inherit from power-up effect, which is a scriptable object abstract class. We can add our create asset menu tag at the top, and in here we can say menu name, and again do power-ups. And this time we'll do a speed buff. We can make another public float amount, because for the speed buff, what we want to do is impact.
Maybe what we want to look for is Unity easily set enemy attributes. Maybe enemy stats. I'm sure I had definitely watched a video before with the way to do this, and I can't remember how I did it. Any stats? It's an opening. There we go. Right, we might be watching a few videos for a little bit, so apologies if I think it's boring. Let's just put it in here though. So you might be able to see it a bit easier. Anyone watching this back?
In our games, we want a good variety of enemy AI behavior. And in this tutorial using scriptable objects, I want to show you how you can just make an enemy behavior in your assets folder, and then click and drag that into some variable on a script, and then get interesting enemy behavior out of it. So I have this Unity project here, and in my game I actually have a player I can move around with a health bar, and I have this red square that's going to act as our enemy, and right now he doesn't know how to do anything. And right now if I walk my player into the square, it'll actually do a little bit of damage to me. If we take a look at our enemy game object, we see we got a rigid body, a box collider 2D. I have this damage on collision script, and it's pretty straightforward. Just for the sake of this tutorial, I'm seeing if we're colliding with a player, and if we are, well then we're getting the health script and, dealing some damage. And then the enemy also has this movement script, which just takes a rigid body, a float speed, and I have this method called move towards target where we pass in a vector 2, and then we're just telling this game object to move towards that position at the speed, and that's it. So pretty simple stuff here. But again, right now our enemy, it has some components with some functionality, but doesn't know how to actually enact AI behavior. And we want to design the system in a way where, one, we can play around with things quickly in the inspector by just plugging and playing with different behaviors, and also kind of decouple these things so that wherever our AI behavior lives can kind of just focus in this one component or script or scriptable object, so we don't have to really mix our systems up too much and make things coupled and difficult to work with going forward. So let's go ahead and make our first script to do this. I'm going to make a new C# script, and I'm going to call this brain. It could also be called like AI behavior or something like that. And if you watch my power up video, we're going to be doing something similar here. You can get rid of start and update. And what we want to do is actually make a template for all of our AI behaviors going forward.
Okay, I think we do want to have a look at this, but not quite just yet.
If, like me, you're designing a rather largely scoped game, you're probably someone who also likes to design tools that make their life much easier whenever they can. I've frequently found myself strictly and methodically writing out lines and lines of code, populate lists, menus, and drop-downs in the editor with the types of data I want, and then programming more lines of code to tell the editor or runtime application what to do with it. I hadn't realized until recently that there was a much easier way to do some of the things I've been doing. One of the most powerful and flexible items in your inventory as a tools programmer is being able to tag parts of your code with custom attributes and have your code figure out what to do with it later via reflection. This can be a great way to populate custom menus and present data to designers in the editor without needing to fetch all of it manually. Hi there, I'm Matt, and welcome to Game Dev Guide. In this video, we're going to take a look at how to use custom attributes and reflection in C# to dynamically populate our editor tools and create automatic functionality at runtime. We're going to write our own custom attributes to fetch data from our project, and then look at how we can use the reflection namespace in C# to iterate through our project.
Right, is this still an active channel? Because if so, I'm definitely subscribing to this. Yeah. 3 days ago, 2 months ago. So it looks like every couple of months there's videos coming out. It's good. Definitely worth to subscribe. Oh no, I am subscribed.
Project and reference data from these attributes. We also
Fair
look
enough.
at a few different examples of how reflection can be used to fetch data values at runtime and why that might be useful to you in your project. So let's go ahead and get started. Let's imagine that we're working on a game with a team and we've been tasked with presenting data in the game to the designers. The designer would like to be able to reference data values directly, sometimes so that the localization can print them and other times so that they can do logic checks on the data. I have a couple of scripts here with some fields of data that I'd like to expose in the editor. For now, I just want to use this editor window to show a list of these fields. Let's start by creating a new script called exposed field attribute. This will be used above any field we want to expose in our editor window. Attributes are essentially tag objects we can use within our code, so we can add properties to them for other parts of our code to reference. At the top of our attribute class, we can coincidentally add an attribute to tell C# where this attribute can be used. We want it to expose fields in our editor window, so we'll set the attribute usage to fields only. Then, let's go through and add this attribute to the fields we want to expose in our editor. Now we've tagged our types in our script with our own custom attributes, let's head into our editor window and use reflection to display the fields. Reflection is a C# namespace that allows us to dynamically create an instance of a type, bind the type to an existing object, or get the type from an existing object and invoke its method or access its fields and properties. In a nutshell, it lets you gather and iterate over data in your project dynamically. Let's start by getting all of the assemblies in our application using the app.domain.currentDomain reference. Then let's iterate through all of our assemblies and get the types within that assembly. Let's then iterate through those types and get info about its members. The member info returns info about a type.
So I'm not sure this is really relevant for the moment, but it also looks like it's something that could be quite interesting to
properties, methods,
to understand.
Events, and nested types. We could use the get fields method instead.
Oh, I just realised it's still got the research window on there. Sorry.
By default, this method only searches for public members, so we need to pass in some binding flags to make sure we get our private fields returned too. From here, we'll iterate along our member info and see if the current member has any custom attributes. If it does, we'll see if it has our exposed field attribute and then add this member to a members list. Now we have a list of members from across our project. All we need to do is display that info in our editor window. As you can see, we now have a dynamic list in our editor that returns any field with our exposed field attribute. If we go into our code and add more attributes, these will also show in our editor window. Retrieving information from a type and using attributes like this can be extremely useful. Let's suppose we want to give these fields a display name in our editor. We can do so by extending our attribute to have parameters. In our exposed field attribute, let's create a new display name field and define this as a parameter when declaring our attribute. Then let's go through and assign some display names for our fields. Back in our editor window, I've declared a struct that takes both the attribute and member info and adds it to our list. Then when we're displaying the info, we just pull the display name from the stored attribute. And now our window is full of more readable names. Passing data through attributes like this can be incredibly powerful when it comes to building custom editors. So our window is populated, but it's not instanced. What if we want to dynamically retrieve data at runtime? I want our editor to show and track these values, so we're going to need to change things up a bit. Our game manager class creates instances of our data classes at runtime, so we just need to update our editor to use the instances from our game manager. This is actually pretty straightforward. In our editor, we can cast our member info to field info, and from here we can read the field using the getValue method and pass in our instance type. When our game is running, our editor window now displays the values from our instance class. This little button increases how much money we have by performing some labor. As you can see when I press it, our reflected reference updates to display the new value. We're now dynamically retrieving and displaying this data. So we now know how to get references to instance data dynamically. Let's look at some of the things we can do with it. One of the most common things we do in game development is inserting data into text. Now, usually the data would be presented by the designer placing tags into the text, and then you'd probably write a pretty lengthy script to pass those tags and replace them with the right data. I hate this method because it requires a lot from both the programmer and designer. You need to keep memory of all the tags and their syntax, and adding new data or tags tend to have quite a significant overhead. Let's look at how we can use our attributes to replace these strings and dynamically pass data into our text without the messy overhead of a strict text syntax. I've created a new class called exposedValueSelector, and here we simply need a string called fieldName. This will act as a reference to the reflected value we want our text to display. Let's create another script called exposedValueText. This will be the script that does the work replacing the text with our selected values. In here, we'll create a text area string. We'll then also create an array of exposed values. Now if we add this to one of our text boxes, we can see that our exposed value element.
Right, what we're going to start doing actually is I'm going to start. Right, where is our options for? Where's our options for what are they called? Playlists. Where? I think this is changing the appearance, isn't it? Oh, that's so useful. What's this button called? Mini player. How do you hide mini player? I'm sure one of the settings in here is hiding the option. Playlists. Nope. Oh, that's quite useful. Right, not what I'm looking for though.
Elements are just string.
I'm sure there should be an option here to add to a playlist, right? Save. Oh my god, it was right there. Right, let's do a new playlist of Unity tutorials. I suppose this is an optimization, isn't it? Let's put this into optimization. And we can come back to that later.
Text fields. We could manually type the field name in here, but let's do a bit of work and present something that we can easily select. Let's create a property drawer for our value selector. In here, we'll perform some reflection and add all of our exposed fields to a list. I'm using a separator in the field names to break our pop-up into submenus. The final thing we need to do is tell our property to assign our selection to the field name and vice versa. In our inspector, our list should now display all of the exposed fields. Let's just remove these tags from the text here and replace them with our identifiers. The last thing we need to do is tell our text script to dynamically pass the identifiers and our values at runtime. For performance reasons, let's grab the exposed reference info once and store it in a static dictionary. Then we just have to go through our exposed value selector and grab the field from the dictionary. And then we just get the value from the field like before. As you can see, this now takes the pressure off to remember all of the tag syntax in your text system. You can now dynamically assign values to your text, and if the data can't be presented yet, simply adding the attribute will add it to this list and automatically present the value in our text, saving a significant amount of time and effort in both stages of writing our text. And that's about it for this video. Obviously, these are just a couple of examples of how we can harness the power of attributes and reflection, but hopefully it's given you a few ideas of how you might be able to take advantage of.
That's interesting, but not what we're looking for.
In Unity, enums are usually used to represent some sort of a data. Now, in our project, we have two types of weapons, a sword and a bow. So I have decided that to let the character know what type of weapon is he holding, I will define an enum weapon type, and I have two types, sword and bow. And my weapon script that defines each pickable weapon has this weapon type that it is passing to a weapon manager placed on the character. While in a simple project this would work great, what happens if I have another weapon, for example this axe? How can I add it? Well, to add it, I would have to go to my script and add another enum and possibly modify the weapon manager as well because it is also dealing with this enum. And if we add another weapon, I would have to repeat the whole process. And I believe that instead of using enums, what we can do is use scriptable objects. And I want to show you a solution using those. Hi, I'm Peter, and welcome to Sunny Valley Studio Tutorials. Before we start, the assets that I'm using are from Quaternion object, and let's add the axe object. Okay, here is our axe. Great, but now I can select my pickable weapon, but I cannot select the axe because the enum doesn't contain it. Okay, no trouble, I can simply edit the weapon script, right? I can add the axe here to our weapon type, and all should be well. Well, let's go back to Unity, and now I can select my pickable weapon, weapon script, and I will select the axe. Now, what happens in our weapon script? Well, our weapon script uses onTrigger enter to detect when our player has collided with it, and it informs weapon manager that is on our player that if the weapon manager exists on the colliding object, we are going to want to equip this weapon type. So, the weapon manager equip weapon type. If I go to this definition, the weapon manager contains the prefabs of our weapons, because since we are passing the enum, we need to from somewhere get the prefab of the weapon, and contains a reference to the weapon slot. So in the equip weapon, we are getting this weapon type. We are playing some sound, we are saving the equipped weapon as the weapon type. We are creating this game object weapon by selecting weapon type, the sword or weapon type with bow in a switch statement, and we are returning this game object, so prefab of our weapon, and we are destroying the previously equipped weapon and instantiating the new weapon and assigning it to our player avatar. Now great, but our switch statement now doesn't cover the weapon type dot axe. So what can we return here? I would like to return an axe prefab. Now I do not have it in my game objects references, so I will add the axe here, and now it should all work. Let me save those scripts, let me go back to Unity. As you can see, it was already a lot of work. Now I need to also check if my character animated object has the weapon manager script on it, and if this
then you have to assign, yeah.
I'm going to drag it here. So now I can press play. Okay, we are in the game. I can pick up the bow, but I can also pick up now the axe, and now I can check my character animated that the equipped weapon is indeed the axe. But if I stop the game, I haven't defined none or nothing in my equipped weapon, so weapon type. So I have always this sword equipped, although my player doesn't have anything. So those little things about enums make working with them difficult for things like those weapons, because every new weapon that we want to add needs to go through the same process of modifying all the scripts in our game. So the problem that we have is adding new weapon is problematic. And what is going on here? Well, the problem overall is that the enum is a wrong tool for the job. Now don't get me wrong, enums are very useful, especially when defining things that does not change. For example, traffic lights only have red, yellow, green, and cardinal directions usually are defined by north, east, south, west. And if we are using encode for each direction in direction enum, so that we select enum direction north, direction east, direction south, direction west, it is much more readable compared if we were using, for example, vector 2, 1001 to represent those same directions. The main difficulty that we have is that every change in our enum requires us to recompile our scripts and modify them. So that's why let's consider scriptable objects. If you haven't worked with those, scriptable objects are data container, and they can be created inside Unity Inspector because we can add to them create asset menu, so we can right click and create those scriptable objects. They can store ref fields, so we can define name, for example, or weapon type, or a prefab for our weapon, as well as methods if we need to have some methods. Now, why should we use those scriptable objects instead of our enum? Okay, this is the same thing that we have seen previously, but now instead of enum, I have created in the data folder a weapon data SO scriptable object by extending the scriptable object class. And I have added create asset menu to be able to create instantly create a new asset inside the Unity Inspector. Now, what we can store here is, for example, public in the damage string weapon name, as well as the game object weapon prefab. Now, if I go to Unity, we can select the data folder, and I have defined the bow weapon data, and as you can see, I have assigned to this a bow weapon prefab. I can also right click, create a data and weapon data, and I can create, for example, axe weapon data, and I can give it some damage value weapon name axe, and I can select my prefab axe weapon prefab. Now, the weapons, so the pickable objects in our game, contains the same weapon script, but now, instead of having a enum, it has a private field of type weapon data SO. So we can assign this weapon data SO object to our weapon, and onTrigger enter now sends to our equip weapon method the weapon data SO object. And if I go to our equip weapon definition, now it gets this weapon data SO, and from this, it gets its prefab for our weapon, as well as in our weapon manager. Now we can save the reference to our weapon data SO, so we have access to all the data about the weapon, because as I have shown you, we can add additional fields here like public in damage or anything else. Anyways,
this looks roughly what we want to do.
and modify the existing logic. Right now, we can
So I might rewatch this in a slower speed after.
And I can now select my weapon axe, just like we did before. But now if I select the weapon script on it, all I need to do is select the weapon data and swap it for my axe weapon data that I have created just a while ago. And now if I press play, I will be able to pick all of those weapons up without any trouble. Right now, our character animated object, our weapon manager script, doesn't contain any weapon data SO. So we have no problem with this, where we have this enum set to be stored by default. Now if I go to my bow, I will have this bow weapon data in my weapon manager, as well as my character now carries a bow. And if I go to my axe, now as you can see we have the axe, as well as in the weapon manager we have equipped weapon, axe weapon data. So again we have access to all its data that is defined in the scriptable object. So this way we have used scriptable object and a bit of object-oriented design. So instead of using this enum, we can save the weapon data as a reference, which is serializable to my save file if I want to save or reload the state of my game. And to add more weapons, I can simply create a new weapon data object and define its properties, and it will all work with my current system because every weapon data so has the same parameters. So I will need to define the same parameters that are currently used by my logic. And of course, I can go to weapon data and add public int health or whatever we want to have here to define our weapon data, and we can simply access this through our weapon manager. Okay, so to summarize, in case you are starting to see that your enum is growing,
I think this is basically what we're looking for. So let's put that at the end for the moment. And we've got this one as well. I think what I'm going to do, just a quick break, just to stretch and like wake my mind up a little bit. Oh, sorry. I might put some more some different music on after as well. So let's swap back over to the screen, and we're just going to do a quick be right back. No, not starting soon. That one. There we go. Right, back in a sec. Right, sorry about that. I think we're going to swap over to a bit of stream beats. Let's do some chiptune. We're just going to pause this. Okay, I think that sounds about the right volume level. That'll be good. Right, swap back over. We're going to listen to a little bit more of this.
Scriptable objects are data containers which live outside the scene and are also persistent, meaning that their values do not change when the scene reloads, unless you program that functionality. So they're a great way of storing data you may need, such as the health, enemy attack, etc. However, there is another use for them. And if you're interested in learning more about scriptable objects, I recommend my previous video before watching this one, which explains scriptable objects, what they are, and how to use them and their benefits. But there's also another use case for scriptable
Right,
objects.
where's the previous video? Ultimate introduction to scriptable objects. I think this might be. I think we're narrowing down on what we're looking for. Only like 2 hours. 2 hours now.
Unity game engine, and this is called scriptable scriptable objects. I'm going to show you what they are, how to make one, how to use them, when you'd want to use them, and I'm going to compare them to other methods that don't use them so you can get a better idea of how they work and why you might want to switch over to using them. Scriptable objects can make it easier to prototype, you can organize your code to make it easier to understand and change for both coders and designers, and this results in quicker iteration times on both sides, especially for designers who might not
I'm just going to dip the
want to change a couple of values around. And speaking of game
Spotify a little bit so we can hear this a bit better.
Machinations is the game balancing platform, which you can map your entire game and then run simulations to balance the parameters, which is great for fast game design iteration. How do you know if you need machinations? Well, you're swamped with spreadsheets, text documents, diagramming tools, and whiteboards, so you know that balancing is more than a circus act. It's the cornerstone of great player experiences, and you want to make sure to get it right. You believe that guesswork is for the fortune tellers. Game designers should rely on proven science. You want a reliable way of predicting player actions even after thousands of iterations. Machinations will help you get laser-focused clarity, rapid prototyping without writing any code to help you balance your player's experience. And this can save you up to 90% in balancing and iteration time, which is huge. You can start from hundreds of ready-built templates, or you can quickly create your own by using the prefab library items. You can easily bring your whole team in and work with them on the same diagram by using the live collaborative editing feature similar to Google Docs, so you can make edits in real time. They have extensive and awesome documentation, YouTube tutorials, and they host regular webinars, so picking it up will be a breeze. There's a plan that's free forever that gets you really far. You can try it out by using my link in the description and start designing your own machinations. So, scriptable objects. Everyone's talking about them. What are they? Well, a scriptable object is just a fancy way to say that it is a container of data. So in its primary use, they are meant to contain data that you might need to play your game. For example, let's say you have an enemy, and your enemy has different stats, such as health, speed, and a type of attack. Well, instead of creating a mono behavior to store this data and attaching it to your enemy, you can make a scriptable object instead to store the data. Now, the main difference between these two approaches is that a scriptable object is an asset. So this is an asset within your assets folder, and you cannot initialize a scriptable object in your scene, so this is a project level asset. This also means that this does not depend on the scene in any way, so it is scene independent. Any game object from any scene can access this data. You do not need to get a reference to another object in the scene. Now, with a mono behavior, usually what you would do is that you would have this zombie, you would make a prefab out of it, and if you want to change the stats, you would make another prefab variant out of it with the new stats. But you can see that this can quickly add up to having a bunch of different kind of prefabs. And what happens if you change something in one prefab that you need to now change in all the other prefabs? And that's because the zombie has a direct dependency to those stats. So when you have dependencies, when you change something, it can cause something else to break, or you might need to change other objects or scripts to account for the new changes. Scriptable objects makes our life easier because we extract that stats information from the zombie and we put it in this data container within our project level that we can easily duplicate and have different scriptable objects for our different enemies with different stats. So there's a lot more to scriptable objects, but right now I just want to show you how to make a scriptable object so it's easier to follow along. So in your assets folder or wherever you have your scripts, you can right click and create a new C# script, and you can call it whatever you want. In this case, I want to make an enemy scriptable object, and usually you have the word scriptable object after what you want to make a scriptable object of. So for example, I can just call this enemy scriptable object, and I actually already have a script like this on the scene, so I'm just going to add a 2 to it so it doesn't get confused. So once you have this script, you can delete everything for the most part, even these 2 using statements from system namespace. Just make sure you have using Unity engine, and all we have to do is instead of extending from mono behavior, we can now extend from scriptable object. And ta-da, you have your scriptable object. But we actually have to add some data fields into it. So let's say our enemy has different properties such as health and speed. So you can just declare as you would any other script, public int health, and you can set it to a value, and you can also put speed, so you can do public float speed. Maybe set that to 5. You can also make these private with a serialized field, as so, but I'm going to want to access these from other methods, so I'll just leave them public for now. Or you can make a getter and setter as well. So this is like our blueprint, our recipe, and then what we can do is in the assets folder, we can create an asset out of this script that contains our data. Unfortunately, out of the box, this is not supported directly.
Double check that.
Maybe set that to 5. You can also make these private with a serialized field.
Okay, I think this is what we want to do though. So let's make a new scriptable object here. So character scriptable object. And we want to do this whole getter and setter thing. So let's say public float. Well, float reference actually works. Just do caps speed. And then how do we do the getter and setter like this? Get private set. I'm pretty sure it was something like that. Oh no, just set. Alright, set. How do I? Okay, that's in the equals, right? So it's here. Equals 100. Like that. This needs to be a float reference, not a float. Can we just do that? Maybe. We'll come back to that.
So, but I'm gonna want to access these from other methods, so I'll just leave them public for now. Or you can make a getter and setter as well. So this is like our blueprint, our recipe, and then what we can do is in the assets folder, we can create an asset out of this script that contains our data. Unfortunately, out of the box, this is not supported directly. We have to make this accessible from the assets folder.
Let's just have a quick look at our audio manager and see how we've used these. So we just called these a certain name. I'm sure we were meant to do float reference here. Because I think float reference allows us to, it allows us to use a constant bool in the inspector, or we override it with the variable that we pass in. Rather than what we've done here, we're just passing in the bool wherever our audio manager went. Here we're just passing in the actual variable, and there's no way to override it. But that's not important right now. So that's kind of what we want to get to, but let's just do a normal public float. No, just float. Speed. And we're going to use the same thing. But we're going to set it to 5F to start with. Just going to use that.
To do that, we can add these two brackets here and type create asset menu, parentheses. Then we can add a file name, which is the default file name that will be given to our created asset. In this case, I'll just call it enemy scriptable object. And you can also add in a menu name. So when you right click in the assets folder, a bunch of stuff pops out, and it's sometimes hard to see what you want to select. So this will make it easy for us. So we can put it under a folder called scriptable objects, dash, and then we can call it something specific. So in this case, I'm just gonna call it enemy 2. You can just call it enemy 1 in your case. All right, so if we go back to the editor now and we right click create, you see that now there's a new option here called scriptable objects. And this will have all of our scriptable objects that we made if we put it under this menu item. So now we can create an enemy 2 scriptable object, and we can name it anything we want. In this case, if we have an enemy of a goblin type, we can just name it goblin enemy. And you can see now that this is an asset in our project with health and speed, and we can change it in the inspector. So it is important to note, since this is an asset and it's not bound to our scene, that means that when we change the values, either through here or through code, while the game is running, or even while the game isn't running, then those values will be saved. Unlike normally, when you press play mode and you change a value in a component, for example, if you change this slope limit of the character controller while in play mode and you exit play mode, it will not save that value. With scriptable objects, it does save that value, so it makes it really nice for prototyping. And if for some reason you didn't want it to save the values, you can easily write a helper function to instantiate a new scriptable object through code and change those values at runtime, and that wouldn't affect the original scriptable object, which I'll show you how to instantiate them through code as well. Alrighty, so now I want to show you a more concrete example using this space here. I'm going to open up the script that I already have created. So the only difference here is that we are also taking in another parameter called enemy attack scriptable object. So let's say you have an enemy, and let's say your enemy attacks player. Now, what of your different types of enemies have different kind of attacks? Well, what you can do is input scriptable objects within other scriptable objects. So in this case, we're inputting this enemy attack scriptable object, which if we go to, it's just another scriptable object with other parameters such as attack damage, attack range, and attack sound, which is a reference to an audio clip that we can play in our script whenever the zombie attacks. So this makes it super easy to swap in different attack types when we want to test on either different enemies or we want to test the same enemy, test different attacks. And I just want to highlight that another benefit of using a scriptable object is that it can save you memory and performance. For example, in this scriptable object, we are referencing an attack sound. So let's say we have a bunch of enemies on the scene, and if we were using mono behaviors, we need to create an instance of an audio clip every time we instantiate a new prefab. And so now you have a bunch of instances of something for each prefab, when in reality, if you can just reference the existing instance within the project, then you wouldn't need all these created instances. Just like in this case, we have a reference to an attack sound, even the attack damage and attack range, we only have one instance of these variables instead of having an instance per prefab of each enemy. You can see if we have 1,000 enemies, we need 1,000 instances of the enemy prefab to be instantiated, and each of those instances would need to put these variables in memory. However, since the scriptable object lives in the assets folder, there's only one instance of it which you cannot instantiate. Now this is only in memory once instead of 1,000 times. Alright, so back to the editor, I just want to show you a more concrete example using these enemy scripts that I've made. So in this case, I have a zombie with an enemy controller, which the enemy controller, basically, all we're doing is getting a reference to the animator, and I'm just storing the different animations that it has so I can access it easily, like the IDs of each animations. Then what I'm doing here on start is that I have an audio source attached to the zombie. So what we're doing here is we're referencing this enemy scriptable object, which if we scroll up, all we have to do is type private or public enemy scriptable object, which is the name of the scripts that we made, and our variable name, just like any other variable. So you can do enemy scriptable object dot, and then I'm going to reference the enemy attack type, which is the other scriptable object that I made that has the type of attack dot, and then we have these public parameters that we can access. And in this case, it's called attack sound. So basically what this script is doing doing, it's saying that while the enemy is not in range of the player for its attack, then follow the player, and once it is in range, then attack, and wait a couple seconds until starting to follow the player again until it gets in range again. And for the range, we use the property from the scriptable object, enemy scriptable object dot enemy attack type dot attack range. And this is just a simple example to show you how to reference scriptable objects within the scene. And so if you add the enemy controller to your zombie, you can now drag and drop your created asset directly into the inspector. In this case, I can drag the enemy scriptable object that we made with right-click create scriptable objects enemy right into here so we can use it. And now you can see that when we run around, the zombie will chase the player until it's at the certain range of the player, which we can go to the project and click the scriptable object, zombie attack, and you see that the attack range is 5. Now if we change it to 1, you'll see that now the zombie gets closer to the player before attacking. And you see that when we stop pressing play here, the value is kept in the scriptable object, which is awesome. So you can easily use this to do any kind of other system, such as player stats, health, power-up stats, keeping a list of audio references, a list of objects, making an inventory system, or creating a save system. And it's great because this is persistent, so the data will remain the same, regardless of whatever scene you're in, so it's scene independent. It allows you greater flexibility because you can easily drag and drop different scriptable objects in to test different parameters or values, so you can isolate testing different features more easily because you'll have reduced dependencies on different scripts, which I'll actually explain a little bit more of in a minute, and it's not bound to play mode. So I do want to mention that there are some functions that you can call within scriptable objects. The functions are awake, on enable, on disable, on destroy, and on validate. Now the execution of these is a little different than mono behaviors since this does not exist within the scene space. And the documentation on this isn't super easy to understand. Fortunately, I found this great forum on Unity by GetBrinks explaining the different callbacks and when they are executed. So the await function is mostly called when a scriptable object is created. In this case, it could be either in the editor or at runtime, which you can create scriptable objects at runtime, and I'll actually show you how to do that. It's also called when a scriptable object is selected when you click on it in the editor, although I'm not sure why, and GetBrinks also seems to be confused on this. On enable is called when the scriptable object is loaded, but this is called after await. It's called if the current scene reloads and the scriptable object is being used, and it's called if we enter play mode and the scene that loads also references a scriptable object. On disable is called when the scriptable object goes out of scope or is unloaded. So if a scene is loaded and there are no mono behaviors referencing the scriptable object, then on disable is called if the current scene reloads and is currently referencing a scriptable object. On disable is called. It's also called in play mode when you enter a scene that has a scriptable object. So on disable is actually called first before on enable is called, which is interesting. And on destroy is called when the script is destroyed. So since this is a project level asset, this can either be that you destroy it through your script in code if you delete it from the assets folder manually, or if you created a new scriptable object at runtime and you either destroyed it, quit the application, or exited play mode. And you can read through the rest of this forum if you're interested in more of the intricacies of the execution orders. It's quite complicated and it seems like the documentation doesn't clearly explain the functions well and when they're executed. So just to show you an example, I've put the debug.logs in these functions, and this scene has our zombie, which the script references our enemy scriptable object that has these debug.logs. So if we click play, you'll see that on disable is called first, on validate is called, and on enable is later called. And I forgot to mention that on validate is basically just called when a script is loaded or the value of the script changes in the inspector, which this can be good for debugging. Be careful if you use these functions because the execution orders can get a little messy. Make sure to print out the execution orders because if you're trying to reset something, you see await was not called here. It's called when a scriptable object is created. But you see if we create a new scriptable object, right click create scriptable object enemy, press enter, you can see that in the console await and on enable is called. So just keep that in mind. And now I'm going to show you how to instantiate a scriptable object through script. So I've already written a script just to show you how it works. This script is called instantiate scriptable object, and this is just a normal mono behavior. So all you need is to get a reference to your scriptable object, and this is the instance we're going to create. And then you can call this method scriptable object.create instance. And then you pass in the type of the instance that you want to create. In this case, we want to make an instance of type enemy scriptable object, and you have to cast it using type of, so we can get the type and pass it into this function. And then all I'm doing here is equaling it to test, which you actually have to cast it. This is the cast, meaning we're converting whatever type this is returning. So this is returning a scriptable object, and we're casting it to an enemy scriptable object so that we can easily reference it in our script and its values. And then we can use it as normal. We can do debug.log test enemy attack type attack damage. You can access your properties as so. And then if you want to destroy the scriptable object, there's a function you can call called scriptable object.destroy. You pass in the scriptable object that you made, and then this is just how many seconds you want to wait until it is destroyed, which is a float. So just to show you how this works, I'm going to create an empty game object and attach this script here. And then if we press play, you'll see that first on disable is called twice, then on validate, then on enable, then on validate again, then on enable again, then await, then on enable. And this no reference exception is just because I actually didn't pass in an enemy attack type to the scriptable object. But besides the point, after that on disable is called, and then on destroy, and on disable is actually called again after that. So you see there's lots of stuff going on here, so just be careful on the script execution order. Additionally, I'm not going to cover it in this video, I'm going to cover it in another video. There's another use for scriptable objects called event-based messaging, and it's where the scriptable object kind of acts as a middleman between two different scripts or components, so we can decouple the code, which basically means to separate or to remove dependency onto components. And when you remove dependency, it makes your life easier, makes it easier to test, more flexible, and easier to debug. So I'm gonna do this video
Yeah, we want to do stuff like that as well. Let's not. So what I like to do normally with tutorial videos like this is watch it all at double speed, figure out roughly what it's doing, and then watch it in more detail and follow along at the same time. So I think this is another good one that we want to come back to. And that one after looks good. Let's see what else have we got. Nothing else. Right, so I think these three are the ones that we're looking for here. Again, we've gone on a bit of a tangent away from the sprite swapper, but maybe let's pause that for a bit, and we'll come back to that when we want to look at that in a bit more detail. I think what we want to do is do a new folder here. Let's do Sprite libraries. And then we'll move you in here. And then in our character, let's say our animator is this, and our controller, for the moment, we're just going to do like King of Hearts. Right, I assume we're going to have loads of errors. There's no sprite in this anymore. Let's just see what happens. Yep, okay. So, how does this sprite library work? Create an empty game object and name it hero. Add the sprite renderer component to it. Okay, so I think what we want to do is we want to add our sprite renderer components to the animator. And assign one of the sprites in the sprite library to the sprite property. So, can we do this? No. Can we do K hearts? Let's call this K hearts library. And can we see that here? No. But this is one of the sprites we're using. And I think we were sizing it up like this. Then add the sprite resolver. So one of the sprites to its sprite property. Add the sprite sprite library component and assign that. Okay, and then add the sprite resolver. So sprite library and sprite resolver. So sprite library. And we assign this. Okay, this is looking better. And then sprite resolver. So this should now have the sprite on it. So if we look at our character here, we drop that in there and drop that in there. Then maybe we won't have any cancel that. Okay, so what's happening here? Oh, because we're in the prefab. Okay, we go back to this. So yeah, we've got our animation working. So what we want to do is we want to dynamically assign this, I think. Let me just have a little think about that. Right, I don't know why I'm finding it so hard to focus on this at the moment. I think it's because it's all, like, there's a lot of unknowns going on. So my brain's being like, you don't really want to deep dive into this bit. Let's find something else to distract you. So I want this selected character to drive the animator library. I think. Oh, I'm not sure. I'm going to have a little focus mode break. I think I just need to draw out what I need this to do. Because at the moment I haven't got a clear image in my head for this. So we're going to like be right back a little bit, but I'm just going to put the focus mode on. And set that to What do you reckon? 15 minutes? I mean, 20 minutes is the Pomodoro technique, isn't it? So maybe let's do that. Right, so probably not going to have a lot of chatting, or it's going to be a little bit of mumbling to myself. So back in a bit. Well, a little think about this a bit more. Why? So what I'm struggling to look at now is... Oh, they're there now. I swear that player option wasn't there a second ago. Okay, so that's all mapped. That looks fine. So let's turn that script off. Let's save it and just see what breaks. Because lots of things are going to break. To be fair, not loads of stuff. Okay, the input's not. That's fine. Okay. So this here is saying that when we set up each game object, we're having to manually assign these. Which isn't as much work as making each of these prefabs and making different character controllers and all that kind of stuff. So actually, let's do this. Let's take all of these. We're going to copy these, and we're going to do a new folder and just call this like generic character. And we're going to paste them all in there. And we're just going to call this character. And all of these are just going to take up the names here. So really what we want to do is we want to see what this scavenger's animation clip looks like. tidy this up a little bit. Just doing this to procrastinate, aren't I? Hey Runa, thanks for the luck. Hope you're good. Right, it's not the most interesting bits at the moment because I'm just procrastinating while my brain's trying to think on figuring out how this is all going to fit together. Right, that's nice and organised now. Oh, that's so annoying. That's taller. I'm not going to be able to get that to line up straight. Unless we rotate it all around. Oh, do I want to bother with that? No. No, we're going to leave it like this. Okay, so this is going to be our character animator. So we need to set this as our defaults here. This just needs to be jump. And this will just be slam. Should be down here. Slam land. Jump. Idle. Grab attempts. Can I just edit this? No. Grab success. Holding. And throw. Right, I think they're all updated to use these actions now. Right, so how do I make this? How do I make this scavengers animation sprite sheet? Sprite library asset contains a set of selected sprites assigned to different categories and labels. I think this is going to be the same. Yeah, it's just going to go to this. In a single animated controller, you cannot have one animation clip animating the sprite renderer's assigned sprite, while another clip animates the sprite resolver's sprite key. If these two clips are in the same controller, they will conflict with each other, causing unwanted playback results. Okay. Let's just zoom in a little bit here. To resolve this issue, we advise the following solutions. Separate the clips into separate controllers that contain only clips that animate either the renderer's sprite or the resolver's sprite key, but not both types at the same controller. Okay, that's fine. No issue there, but what? So another sprite asset library here to have it become the main reference to the current sprite asset library. Okay. And then the categories and the entries, that's fine. Label. New. Dragging into an empty space and automatically create a new category. Okay. That's useful to know. So if we go to our sprite library here, and then we go to our, so this is hearts. So we go here, hearts, and we go like, oh. We go here. Can we select multiple of these? No. What if we do this? We lock this. And we go here. And we take all of these and we drop them into here. We just add them to that. Undo that. No. That's annoying. Okay, so 0. Okay, this is really messed up, hasn't it? Oh, it's because it's locked. Can't see what's happening. Right, let's say we took 2 to 7. and we drop them here. No, it's not what we want. It's kind of what we want. I want to figure out how do we set up the sprite sheet? No, we don't care about that. Same category and label names for each corresponding sprite. I can't call these the same name. Oh, let's just apply that. So really, I think it's something through the sprite editor. So we know it's 5x5 split here, but this is just going to do the same names. So how do we change the name of this? Like, I don't want to have to go through and rename each of the sprites. But what I'd want these to be named is just like 0, 1, 2, 3, 4. Maybe let's look in here. So we want Unity, easy way to rename sprites in Sprite Sheet. Alright, this or this maybe, or this. Don't really want to go back into Animancer. Trying to change the name of subsprites of Sprite. Search and try everything I think of. Yep, okay. Let's say I have a sprite sheet that has been split into like this. Any changes to that name? Yeah. Oh, it's the same person who asked the question. Provided the answer. Right, slices, okay. Okay, maybe we have a look at this. So I guess you just put this in a script. Texture importer, get past this texture importer. Nice metadata. So for each metadata individual slice. And that one's gone. Digging some more. Have a look at this. Have a look on the asset store as well. Yeah, so this doesn't really work for sprites. Could be what we're looking for. And it looks like it's a free asset as well, so. Be a bit overkill, but. Renames like Sprite Slices. Anything more recent? Okay, I think we're going to go back to this. We're going to make this somewhere in our code. Right, discard this. Let's do new game object. Slice rename. We're going to do a new script. We're going to call it subsprites renamer to match the code. Now we've got to find out where that script went. Once it's loaded. So just going to be in the assets folder. Yeah. Alright, open this up. Copy this code. Paste it in. Save it. Close. And then if we take this, looks like we should have two public fields, texture ID. So let's, for example, take King of Spades. A new name can just be like Sprite, yeah? And we save that and we run it. So on start, it should take that texture, cycle through the sprites, and rename them, hopefully. Now we go to King of Spades character. Oh, okay. That does look like it worked. Can we do it with nothing in here? So it's just 0, 1, 2, 3, 4, 5, 6, all the way up to... It's just numbered, would be good. Oh, it still doesn't underscore. That's okay, we just need to edit the script. Where was it? Let's move this over here for a second. Right, if new name not equal to null, then we do this. And then we do an else. Do this, but we don't have a new name, and we don't use the underscore. Right. Now run this. I'm not sure if it's going to class this as null if it was empty, but hopefully. I don't think that works, does it? King of Spades. No. So, not null. Not equal to empty string. Let's try that. In here. I wonder if it reruns start. So it's 25 and 50. I think I have to stop the run and restart it, don't I? Yep. Or maybe I might be able to just do this, turn it off and on. Nope. Stop and restart then. That's what we were looking for. Okay, does it remain? It remains. Yes. Okay. Now the question is, if I now go into our King of Spades animator. Yeah, it doesn't know what the sprites are anymore. Oh, that's annoying. Or is that just because there's none in the scene? Let's go back to the other scene. Like, let's have a look at spades. Yeah, it doesn't know where these are now. Oh, we're gonna have to do a load of tidy up here. Right, so what we can do though is we can go back to here. We can go into the sprite editor and recut them. Do a 5x5 grid. Oh no, not 85. 5x5. Slice, and that should rename them all. Yeah. Apply. Close that. And now if we look at our spade sprite. Yeah. Okay, now it's got the animations back. That's fine. So I think what we want to do is I think we want to select all of these, duplicate them or copy them. Can we just copy and do a new folder for let's just call this sprites and paste. Right, and now if we go into our other scene, where's scenes? Scene, test scene. Sure, save. It's fine. And then in our slice renamer, we want to select our sprites. This one. I wonder if we can do this. And we just do a new for each. Texture. 2D. Texture. In. Texture 2D. Let's call that texture 2Ds, and we call this texture 2D, so that in this bump that across, and now we should be able to get a list of them, right? So we should be able to put all 4 in here and just do them all at once. Right, now we run it. Hopefully these all turn to zeros. That looks good. Yeah, nice. Right. So now we've got our assets set up. Right, on that note, I'm going to take a little break. Yeah, just back in a bit. I need to stretch. So yeah, back in. Let's say, what do we do? What's that set to? That's set to 20 minutes. That's too much. Let's just do like 5 minutes should be fine. Little break. I'll probably be back before then. Alright, back in a bit. Right, a little bit longer, sorry about that. So, what we were looking at here was this. So we've set all of these sprites now to just numbers, which if we keep the same pattern for all the sprite sheets, then hopefully that means when we go into our animators, so let's say this sprite is the King of Hearts. If we just apply that to a 0 there, and we do the similar thing here, right? So let's get rid of these two. We want 0 and 1 for this idle. Can I see the values here? I can't, can I? I can see it in the sprite renderer here, but is there a way to view details? Right, I'm still not sure we're doing this quite right. I think we want to lock this. And then can we have another inspector? I think we can, can't we? Oh no, don't want to do that. What have we done? Not maximize. New tab, is there an option for that? Add tab, inspector. Here we go, right. Let's put that on there. Right, so this will show us what sprite we've got. So this is our wind up. We can take those off and put 2 in there. We're going to have another category, which is going to be jump. No, this is slam. Although we're not really using this now. Let's just do it anyway. And then this is jump, isn't it? So 8 to 14. And then this is going to be grab. I think we're just going to call these all grab. And this is 15 to 24. Is there an apply? There is apply. Yep. Right, now, so how do I make a generic idle animation here? Using... That worked quite well, that was quite nice. Get rid of those, don't need those. Don't need this. Do this one. Frame by frame animation. First change the keyframe tangent before continuing the way below. Right, what is a keyframe tangent? When animating by changing the category and label value of the sprite resolver, important to change the keyframe to constant. What does that mean? What? Okay, so it just tells you after this. What's the new category? What? I'm so confused about what this is trying to tell me here. So we have this sprite library asset, right? So we've got our categories. Add a sprite for each frame of the animation to this category. Okay, yeah, so this is what we've done here. Create a game object and add a sprite renderer component and resolver. So this is our animator, right? So we've got our sprite renderer and our why is 0 missing? That should be that. Right, I think we can unlock this and close this window. So we now have our sprite renderer, our sprite library, and our sprite resolver. So open the animation window and select this, which we've done. But our animator, we don't want this controller, we want character. Ah, right, okay. Open the animation window. Select the game option from, game object here. Which really, we want to do here. So hopefully, we've still got that here, yeah. So for the moment, that's that sprite there. This is our character. This should be this right here. Okay, and then instead of this idle animation here, we should do record. Go here, and we select idle 0, right? Go to the Sprite Resolver's Inspector window. Yeah. Select category and label. Ah, okay. Maybe. And let's remove that property. Oh, what is going on there? Sprite key. Changing the category and label of the sprite. It's important to change the keyframe. Okay, we did something wrong here. So this should be 0, right? Is that update if I do 1? No. Record it. Right, this is 0. This one here is 1. Is that doesn't update it, right? That's 0. Why is it saying minus? I don't know what's happening. Ah, here we go. Right, this should be constant, right? Right, let's select all of these. Let's delete them. Okay, so we add this one here. And then here we go this. And we select these. We go both tangents constant. Okay, that looks like. And then we go to here and we do another one. And we make sure this is constant. Okay. Right, do we have an animation now? We have an animation. Right. So now if we make another sprite library, let's just can we duplicate this? And we call this spades. If this works, I think I'm going to leave it at this bit because we've made some good progress. Right, spades. Now this is, oh no, we need to lock it again, don't we? This library, this one. Lock, open, new tab, inspector. Down here. Sprites, spades. Okay, so we're gonna go remove those two. We put those two in. Remove this one. Put this one in. Remove these lot. Up to 7. So we go 2 to 7. No. 3 to 7. Go here. Because we've got 2 here. Yep. Right. 8 to 14. Go in here. This lot goes. And this is the rest of them. So 15 to 24. Go in here. Apply. Unlock. We can close this inspector. And then if we go to our animator and we drop in our other spades library and the spade sprite 0. Oh, we're still recording. We want to delete this key. No, delete, remove the property. Almost. The only difference is this sprite still needs to be this, right? Oh, why is it? Because this sprite is incorrect. This sprite should be this one. Now does it work? So all we need to do now is figure out how to swap these sprite libraries, I think. Because if we swap this hearts in now, and make sure that the first sprite is correct, which is also this sprite here, then that's it. The animation is correct. Okay. Oh, right. I think we're getting somewhere with this. It's quite slow progress, so sorry it's been a bit of a dull stream with this. But hopefully it's been interesting. I'm going to be wrapping up here though. Going to be doing some horror games later, probably Dead by Daylight. Well, actually, definitely Dead by Daylight after midnight, because I'm going to start doing some shrine time again. So looking at the shrine secrets and trying to do builds based around what perks are available there. But we might be starting a little bit later than scheduled 9 o'clock, because I'm going to be doing some games beforehand with friends. So, yeah, I think that's pretty much it. Thanks everyone who's dropped by and lurked, and I hope it's been interesting. Going to come back to do more of King of the Ring tomorrow. Oh, that's the wrong screen. Just realised. Should be this one. Game dev end screen rather than the gaming end screen. Yeah, hope it's been interesting. Check back later for DVD, or check back tomorrow for more game dev. Where hopefully we'll make some more progress now that we've got a better understanding of this sprite swapper. But yeah, thanks. See you soon.